Okay, so Silverson Machines. Who are we? What are we? Well, we're a family company, second generation running the business currently, and the third generation making their way through the business and learning the ropes. The origins of the company can be found in London. Back in the late 1940s, the family at the time actually owned a number of pharmacies and wanted to get into the manufacture of ice cream. But during that period of time, the raw materials were quite hard to come by and they were of poor quality. And to mix up the ice cream premix was quite a challenge. So the chief pharmacist at the time came up with this idea of putting more work energy into the formulation, into the mixing, to disperse those powders and the sugar. And that's sort of was the evolvement of the rotostator high shear mixer. They took the design to an engineering company. That company was called Peter, Silver and Son. That's where the name comes from. And they suggested that rather than manufacturing one mixer, they would manufacture 5, economies of scale. And the family quickly sold those other mixers to other ice cream parlours. And by 1948, Silverson Machines was formed. And by the early 1950s, we were exporting these machines across Europe. So roll that forward now to the current day. As I say, the head office is based in Chesham, which is a small town just on the outskirts of London, northwest of London. We currently have 130 people on site there. Globally, we have approximately 175. The Chesham site is our main manufacturing base, but we have light assembly in the USA and light assembly in Japan, regional sales offices in France, Germany, Poland, and Malaysia. And put together those regional sales offices with our network of distributors, which is approximately 70, we actually offer a global reach with a local expertise. So helping those companies and in those local markets to select the correct mixing device. So in a moment, I'm going to hand you over to Zach, who will run through the most common challenge that our customers see and the application which the company was founded on, which is basically dispersing powders into a liquid. But before I do this, I just wanted to highlight that we will have a Q&A session at the end of towards the end of the webinar. So if you've got any questions, please send those through in the Q&A chat room, and we'll get to as many as we can today. Okay, so now I'll hand you over to Zach, who will take you through the presentation.
So obviously the point of this webinar is to go over powder liquid mixing. So we figured it'd be best to start with some of the most common powder liquid mixing frustrations and struggles that we encounter in this industry. So these include poor powder wetting, long processing times, difficulty processing high viscosity formulations, inadequate particle size reduction, and inconsistencies during the scale-up process from the laboratory mixing to production mixing. These are some of the problems that we're hearing directly from processors with their current mixing technologies prior to using Silverson Machines mixers. It takes hours for powders to dissolve into the liquid. They're losing product in the filtration process when filtering out the agglomerates. Powders tend to glob when introduced into the liquids. And viscous, slimy clumps form around the propeller during mixing. So some of the reasons why these powder problems persist, there's a lot of different reasons. This is just to cover a few of them. We encounter hydrophobic powders, which these are powders that tend to resist wetting and do not go into liquid easily. We also run into hydrophilic powders, as these readily absorb water, and this can lead to rapid swelling, clumping, and the formation of agglomerates. Insufficient shear also leads to incomplete dispersion when using traditional prop blade agitators versus high shear mixers. And low density powders also tend to be an issue because these tend to float or raft on the surface, and they're difficult to get underneath the liquid level. So we're now going to talk about the differences between your traditional prop blade agitators versus a silverson high shear mixer. So some of the most common things that are seen when using a traditional agitator for mixing include poor powder wetting, long processing times, struggles with mixing high viscosity applications, inadequate particle size reduction, inconsistencies in scaling up, and material wasted from the need of filtering out the agglomerates. Where with the silverson high shear mixers, we are able to instantly wet out the powders and disperse them evenly. We are able to mix in minutes instead of hours. We can handle viscous formulations very easily. We provide a consistent, fine particle distribution throughout the batch. And one of the key factors with silverson mixers is that we offer a seamless lab to production scale up, meaning that if it works on the lab scale, we can also produce the same results with our production scale mixers. And lastly, we are able to fully utilize the powders, as this maximizes the yield and prevents the need for filtering out those agglomerates that you typically see with a traditional prop blade agitator. So we're now going to show you a video of a conventional agitator being used versus a silverson high shear mixer. So as you can see in this video, the conventional agitator, as the powders are added, they form agglomerates very quickly, and they're very difficult to disperse those agglomerates, where with the silverson laboratory mixer, we're able to quickly disperse those powders, avoiding agglomerates from being formed, and producing a homogeneous, smooth finished product. We'll see in a second here. Okay, so how does a silverson high shear rotor stator mixer work? Our rotor stator mixers work with two main working components. You have your rotor, which is known as the rotating blade. As shown in this video, the rotor is typically a 4-bladed rotor. And your second component is your stationary housing, otherwise known as a stator or a workhead. We stand apart from our competition because we are able to precision machine an extremely tight tolerance between these two working components, as this leads to more shear and a better end result. These two components work together similar to a pair of scissors, as they are cutting or shearing the products as they are passed between these two components. The tighter the blades are together, the smoother and easier the blades are able to cut the products, just like a pair of scissors. If you have a pair of scissors that's blades are bent or dull, they don't want to cut through the product as easily, where when it is a new pair of scissors and those blades are tight together, they tend to cut through that product very easily. As the rotor is spinning at a high speed, this creates a powerful suction that draws the powders directly into the mixing zone where that mechanical shear is happening. The product is continuously circulated through this rotor and stator. This ensures that every particle gets processed, and by controlling the flow of the product through the rotor and the stator, this minimizes the air incorporation. And the result of using our mixers leads to complete hydration in minutes instead of hours, with no fisheyes or agglomerates and no wasted product through the filtering process. So why this matters to your business? This matters to your business because it provides operational benefits, economic impact, and strategic advantage. We are able to mix up to 90% faster than the traditional prop blade agitators. We're able to increase production and reduce turnaround times. We're able to lower raw material and labor costs, as you won't be filtering out product and wasting any product. You're able to maximize the yield and the functionality. And the advantages, one of the most beneficial advantages, and you'll hear us mention this probably multiple times throughout this webinar, is that we provide uniform performance across all of our models. It's very easy to scale up from our laboratory mixing to our production mixing. This allows you to know that what works in the lab will work in the production scale. There's no reformulation or guesswork, and this is a huge benefit to silverson mixers. So we're now going to cover some of the mixers that we offer. These are the most common mixers that we offer for powder liquid mixing. We'll start with our laboratory mixers, then we'll move into our high shear top entering batch mixers, and then we'll discuss our high shear inline and flash mix powder liquid mixers, and lastly we'll speak of our ultra mix in tank and IBC tote mixer. So to start, our laboratory mixers, these are our benchtop models. These plug into a standard wall outlet that can be offered as a 110 volt or a 220 volt mixer. The benefit with these machines, as mentioned previously with the scaling up, is our tolerances are engineered the same as our production models with our laboratory models, and this is what allows for that seamless scale up. These machines are ideal for small batches, for research and development, testing, and formulation. They're very easy to set up, clean up, and they have intuitive controls on the front fascia of the machine. With our silverson L5MA that we'll show you in a video shortly here, you will see that all the controls are on the front of the machine for raising and lowering the machine in and out of the vessel and controlling your speed. These machines are compatible with multiple mixing assemblies, including our Ultramix assembly, and many of these assemblies are also, they have interchangeable workheads, and to change these workheads and assemblies, it does not require any tools, which is also another great function of this machine. They simply, you remove the knurled nuts and the assembly comes off, and it's very easy to put a different assembly on. So we're now going to show you a video of our silverson laboratory mixers. And as mentioned previously, you can see those easy to use controls on the front fascia of the machine with your amperage and time display, along with the speed control and the rise fall option as well. As you can see, this machine quickly incorporates powders and can handle a wide range of different applications. These machines are typically supplied with a variety of different workheads as well for formulation and development. And as you can see here, they do produce a smooth finished product. This is going to show you the difference between our conventional agitator. As shown here, this is showing that with the conventional agitator, it doesn't implement enough shear into the product. So those agglomerates are formed almost immediately and they're very hard to break down. Where with the silverson lab mixer, we're able to immediately disperse those powders and produce a homogeneous result within a matter of minutes. This is showing another application here. This is the dispersion of bentonite clay. As you can see here, the clumps are formed with the bentonite clay, and it takes a long time to produce a homogeneous result with that agitator, where with the silverson laboratory mixer, we're able to quickly achieve those results within a minute and provide an even dispersion of the bentonite clay. So we're now going to speak of our in-tank batch mixers. These are similar to the lab mixer that you just seen, just for a full production scale. These mixers are available with mobile hydraulic floor stands that allow you to easily move the machine between vessels. This is beneficial when you're mixing multiple different tanks using the same mixer. It also allow you to adjust the mixing height, and this allows for maximum flexibility during the mid-process. These machines are capable of handling volumes from approximately 4 liters up to about 30,000 liters. And these also have interchangeable workheads that can adapt to a wide range of process needs and different applications. And we're now going to show you a video of the Silverson batch mixers being used. So as mentioned before, you can see this is the batch mixer on one of our mobile hydraulic floor stands, and the operator is able to easily lower and raise this machine in and out of the mixing tank. As you can see, this machine is able to quickly disperse those powders without forming any agglomerates, just as it was shown with the laboratory mixer, producing the same results. And you will see that just in a matter of time, it produces a smooth end product in a homogeneous mixture. This machine is also capable of handling very lightweight powders, such as fumed silica, that tend to form dust. As you will see here with a traditional prop blade agitator, these products are very hard to get underneath the surface because these tend to raft on the surface. And even as they do get under the surface, you will see that they do form agglomerates. Those agglomerates are very difficult to break down with the conventional agitator. Whereas, as seen here, you can see that with the Silverson high shear batch mixer, we're able to incorporate those powders and disperse them into the solution rapidly, preventing them from rafting on the top of the surface and preventing agglomerates from being formed. As you can see here with the workhead, there's no agglomerates down in the mixture. It produces a consistent result very quickly. So we're now going to speak of the Silverson inline mixers. These mixers allow for a continuous agglomerate-free powder incorporation. These deliver an aggressive shear and rapid dispersion of the powders into liquids. Now these machines work a little bit differently than our in-tank batch mixers, as these machines are located outside of the mixing tank. They work in a recirculation loop typically, where you have pipe work coming from the outlet of your mixing tank, feeding to the inlet of our mixer, and then from the outlet of our mixer, it typically feeds back into the top of the tank to allow you to continuously recirculate the batch. We do also offer a range of inline mixers that are suitable for continuous operation, or otherwise known as single pass mixing. These machines are ideal for clean-in-place systems and hygienic processing environments, as we offer ultra-hygienic models of these machines suitable for pharmaceutical and food and beverage applications. We do offer a model of these inline mixers that enhances the design of the inline mixers, known as our flash mix machine. This is the most common mixer found in our powdered liquid mixing. This is designed for incorporating powders at floor level for a safer dust-free loading. This is extremely beneficial as it prevents the employees from needing to go up to the top of a mezzanine to load the powders into the top of the tank. As you can see in the picture there, in the video that we're going to show you shortly, that the hopper is at ground level and you're able to easily dump those bags. These machines are especially effective for challenging powders such as gums, silicas, and thickening agents. So we're now going to show you our flash mix range of machines that we offer. So as you will see here, we offer these flash mix powder liquid mixers from range starting at our laboratory scale benchtop models to our pilot scale models for small scale production, all the way up to our production scale models. Our production scale models that we offer, these go all the way up to a machine that is capable of moving liquid at about 375 gallons per minute. And these machines can be fitted with a wide variety of different valves, hoppers, and other intuitive components that can be fitted with our machines. As you can see here, we offer ball valves, butterfly valves, pneumatic valves. We offer a stainless steel mobile sack table that is designed to be able to put your bag of powders on the top of the sack table and cut it open and load it in to the powder hopper without needing to hold the bag. We also offer a powder wand assembly. As you can see here, this takes place of the hopper, and this allows you to pull in the powders, the lightweight powders such as fumed silica that tend to form a lot of dust when the bags are dumped. Allows you to pull the powders directly from the bag at ground level very quickly and easily, and to disperse them into that rotor stator immediately. We also offer hoppers compatible with bulk bags for discharge systems, and we also offer a chemical duty model of this machine, where this machine is designed for those chemical applications. They're fitted with a double mechanical shaft seal with a thermosiphon sealant system, 150-pound ASA flange connections, and specialized elastomers that are suitable for mixing solvents and other applications that can attack your typical elastomers. We do also offer a ultra hygienic model of our ultra mix machines. These come with electropolished wetted parts, specialized elastomers, and ultra hygienic mechanical shaft seals. These are 3A certified and E-Hedge certifiable. Okay, so now we're going to show you the flash mix machine in action. So as you can see, this is one of our production machines. And this is going to display how those powders are pulled directly into that liquid stream. And they're pulled directly into where your mechanical shear is happening with that rotor and stator. And this is what allows us to pull those powders in without forming agglomerates, because the powders are sheared into the liquid immediately. So it doesn't allow the powders to form those clumps or fish eyes in the batch. And as mentioned previously, you will see that this operator is able to easily load the powders from ground level. It's at a height where it's very easy to load, and it quickly pulls in those powders into that liquid stream and disperses them almost immediately. The last machine that we're going to discuss today is our Ultra Mix machine. This is most commonly used for the mixing of IBC mixing totes. This machine utilizes a different designed single piece workhead that produces a high flow, medium shear result. This allows you to preserve the integrity of shear sensitive ingredients. And the slim design of this workhead allows you to easily pass the machine into the IBC through the small opening at the top of the IBC without the need for cutting the IBC tote open. And this provides an axial flow that ensures that no unmixed pockets remain. For anybody who's mixed in an IBC tote, they are square totes, and powders do tend to settle in those corners of those totes, where with the Ultra Mix machine, you're able to quickly pull those powders out of those corners and disperse them. These also minimize aeration and meet hygienic processing standards, as these are 3A approved machines. We do offer a wide range of different size Ultra Mix machines that are scalable from 5 liters up to approximately 7,000 liters. The benefits of this machine are that there are no wear-in components because this is a single piece workhead, unlike the rotor stator design. They do meet the hygienic processing standards, and they provide a much higher flow and more shear than your conventional agitator will. We're now going to show you a video of the Silverson Ultra Mix machine being utilized here. So as you can see there, that's the single piece designed workhead that is hygienic. It is not the rotor stator design. It is a 3A approved machine. And as shown here, you can see that it quickly disperses those powders and puts them into solution very easily. And this is showing that these machines are capable of handling those high viscosity products. And with this single piece design workhead, you will see here that This workhead pulls the products in through the top and the bottom of the workhead and expels them radially through the slots in the side of the workhead, producing your homogeneous result. This is showing our IBC tote mixing station. These machines are commonly used for the resuspension of powders that tend to fall out of suspension or settle at the bottom of these totes. As mentioned previously, they fit into these totes very easily, and they're able to pull those powders off the bottom and out of the corners and resuspend them very quickly. So some of the common applications that we run into in this industry and we're able to work with silverson machines include cosmetics with the dispersion of active ingredients, polymer dispersions, the dispersion of thickening agents, working with carbapole dispersions, which is a very difficult powder to work with for any of those who have worked with it previously. We're also in the chemical and petrochemical industry with the dispersion of fumed silicas into oils and resins into water. We are also commonly found in drilling muds for the continuous dispersion of bentonite muds, and we can even be found in the lube oil industry and oil blending. We are also found in the agrochemical industry, in the pharmaceutical industry, with the mixing of tablet coatings and the dispersion of active ingredients. And lastly, it's not on this page here, but we are also commonly found in the food and beverage industry with our ultra hygienic mixers designed for dispersing those gums, thickening agents, sugars, pectins, etc. So we're now going to show you some real-life case studies. These are customers who are now utilizing silverson mixers. So the first one we're going to speak of here was a cleaning products manufacturer. They contacted us and they needed to hydrate their powders like xanthan gum, CMC, and pigments. They were previously using a fast impeller, but with the fast impeller, it was taking 24 hours or more, and it was still resulting in a poor quality mix with undispersed powders still present, and this was not acceptable for them. The solution that we offered for this customer was the Silverson Flash Mix Powder Liquid Mixer. This is a versatile mixer. It can be used on a wide range of different powders and batch sizes across this customer's production line. Since they were mixing a wide variety of different products, we felt this was beneficial. This machine is extremely efficient. We were able to achieve a superior mix in just 35 minutes, opposed to 24 hours or more, which is a significant decrease in mixing time. This ultimately saved money by energy and labor, and that we are able to eliminate the agglomerates and the filtration stage for filtering out those agglomerates. The results of using the Silverson machines, trials were run at the customer's factory across a wide range of their products, and we were able to achieve a high quality agglomerate-free mixture in a fraction of the time. As mentioned before, the customer was able to reduce their mixing time from over 24 hours to just 35 minutes. We produced a consistent product quality, and they were able to continuously repeat the same results throughout each batch, producing agglomerate-free mixtures. And they were able to fully yield the powders, unlike the traditional prop plate agitator. And this further increased cost savings as they did not need to utilize that filtration stage to filter out those agglomerates. The Flash Mix machine was also cleaner and easier to operate than the fast impeller, and it created less dust, and it allowed the operators to load those powders at floor level as shown in the video before. This company now uses our Flash Mix machine for incorporating a wide range of powders with the same great results through each batch. Our second case study was a customer that was a manufacturer of a soil decontamination product. They were struggling to disperse their alginates into water. The existing process was using an agitator, and this was ineffective. It took several hours, similar to the previous case study. and they were struggling to mix the high viscosity application. The solution that we offered for this was our Ultramix machines. So the company trialed a Silverson lab mixer fitted with our Ultramix mixing assembly, chosen for its ability to overcome the pore flow and the clumping issues, and also was able to easily handle those highly viscous applications. So with the Silverson laboratory mixer, they initially tested their formula by dispersing 100 grams of alginate into 4 liters of cold water. And they were able to achieve a complete incorporation of these alginates in just 6 minutes, which was a significant increase or decrease in the batch time that they were seeing previously. The results of the lab trial led to an on-site trial with one of our production Ultramix machines, otherwise known as our U6 Ultramix mixer. This machine was capable of handling their desired production volume of 400-liter batches. The Silverson Ultramix production mixer mirrored the lab's performance, efficiently incorporating the alginates into the cold water, even as the viscosity increased. This is what we were referring to before, where the machines are built with the same tolerance as our production units. So knowing that they were able to produce their results on the laboratory scale, they were able to produce the same exact results on the production scale. This improved their production by creating faster mixing times, increasing the production efficiency. It provided improved consistency throughout their products. It maximized the yield of those powders, once again preventing the need for that filtration stage for filtering out the agglomerates. And this company does plan to increase their production volumes to volumes of 2,000 to 3,000 liters using the Ultramix. And as mentioned, with the scalability of our machines and the wide range of sizes of these machines that we offer, we will confidently be able to supply them with a machine to handle these batches and produce the same results that they're seeing with their current machines. So to summarize what we've covered today, we hope you've enjoyed today's session. We've covered common powder liquid mixing challenges, the advantages of utilizing a Silverson high shear mixer versus traditional prop blade agitator mixing methods. We showed you a range of some of the different Silverson mixers that we offer and their powder incorporation abilities. We showed you real-life case studies and common applications across a wide range of industries that we see. And we showed how Silverson has helped customers overcome powder liquid mixing challenges. As Matt mentioned previously, we are going to now go into our question and answer session. Please enter any of the questions into the chat, the Q&A section of the chat, and we'll be more than happy to answer any questions that you may have. We are going to try to get to as many of these questions as we can. We are limited on time, so if we do not get to your question today for some reason, we'll be more than happy to answer your question after the webinar.
Okay, thank you, Zach. We've got a few questions coming into the Q&A chat room, so I'm going to sort of just go through those and answer as many as we can, as Zach said, before we end the session today. First question is, how can you prevent backflow to the hopper in case of pump switched off during loading of the powder? The basic design of the FMX is with a manual valve, so you would have to manually switch that off, but we can also have automatic valves as well. So in the hopper there will be a level probe and a pneumatic valve, and they will be linked. So once all the powder has left the hopper, the level probe will detect that the hopper is empty, and then the pneumatic valve would automatically close. So there are ways of handling that and preventing that. Next question, to suck the powder from the drum, what is the parameter we have to be aware of? Distance, the type of powder and distance. We are able to clearly create a vacuum, but the drum or the bag of where the light powder is situated has got to be close to the machine, within a couple of meters, as the suction won't drag it from the other side of the room or anything like that. The other thing you have to be aware of when using the powder feed wand or lance is that it does suck a lot of air in. To fluidize that powder, we have to have air to actually make the powder move. So by using these wands, they are very convenient in many respects, but in other respects they will bring a lot of air into the mix, which may not be desirable. So that's something to consider. What are the different types of workheads we can use? Well, at Silverson we have pretty much 4 basic designs. We have a general purpose mixing head, which, as the name indicates, is generally used for general mixing, general high shear mixing and powder incorporation. And then progressively the apertures in the stator reduce in size. So we would then go to a slotted design, typically used for more fibrous materials, if you're processing fruit and vegetables, doing sauces, that type of thing. Then we have the square hole high shear design, rows of small square holes. This has our closest tolerance between the rotor and the stator, and it's typically used for suspending solids. So we are using this for particle size reduction, not primary particle size reduction, but agglomerate particle size reduction, and grinding down solids in a suspension. And finally, we have the emulsor screen, a series of small round holes, which we've, through empirical testing, we have found is much more suitable for emulsions and creating stable emulsions. All this information, these different designs of screens and mixing heads, can be found on our website. We also have a huge range of specials as well, but they are the 4 main designs that we have, and they are available for all of our machines right through the equipment range, right from the laboratory pilot through to full-scale production. Moving on, this presentation should be available. We'll be emailing you afterwards with where that will be available from, those of you who have registered. Another question here, a lot of powder liquid mixers have a secondary pump to feed the shear pump. Why does the flash mix work without that secondary pump? Well, it's the design of the rotor. We have what we call a high flow rotor, so we're generating tremendous velocity into the workhead, which enables us to do the function of delivering velocity, therefore creating a low pressure zone, which will then absorb the powder. So it's actually the high flow design of the rotor that's within the machine. Another question, does the complexity of the return line have an effect on the machine's ability to pull in powders? Absolutely it does. Installation of the flash mix range the machine is almost only as good as the installation. So we have a lot of videos, a lot of direction on installing the machines. We always try and be on site, whether it's ourselves or our local representatives, during that commissioning and installation stage, and also during the trial stage. There's no question about our trial program, which I'll get onto in a moment or two. But if the flash mix is susceptible to back pressure. So if the discharge of the flash mix takes quite a tortuous route around the factory and goes through a valving bank or through a heat exchanger or something like that, that is enough back pressure to slow the velocity down in the machine, which will then in turn reduce its ability to absorb the powder. So our basic advice is the feed pipe and the return pipe to the FMX must be A, as straight as possible, and B, as short as possible. But there are things we can do to assist with that, but it must be, as I say, as compact as possible. And also the pipeline diameters. There's no point in putting a 1 inch line on a machine that requires a 2.5 inch line. It just reacts as a restriction, and therefore not enough flow will travel through the machine to create that negative pressure to absorb the powder. So there was a question here with regards to the demonstration equipment that we have. Yes, we have a good inventory of demonstration equipment. That tends to be where we have regional sales offices, but most of our independent distributors will also have some trial equipment available themselves. Typically, the trials are free. There's usually a free time period for that. We ask that the shipment is covered, and then there's a small free test period for you to trial the equipment. Most of the units are available. Of course, we can't keep absolutely every single variant, but we are able to, all the time, we're able to prove a principle that high shear mixing, or Silverson's high shear mixers, are suitable or not, in the case, for the product being mixed. Do you have any recommendations for powders that tend to foam when mixed? Yes, not to use the wand would be one. As I said, that sucks in a lot of air with the powder. But normally, when you're using the hopper, okay, let's start again, sorry. So when you're using the hopper, there is always air within the powder itself. If there was no air, then the powder would be solid and it clearly wouldn't flow. So there's always going to be a certain amount of air within the powder. However, if you're putting in a number of different density powders, one trick to use is to actually blend those powders together. And they will then sort of almost form a slight plug. One of the challenges with sugar, granulated sugar, is that the granules create almost a suction path through the body of the sugar where air is drawn. So that actually slows down the absorption of sugar. What we tend to find with sugar formulations, there tends to be a gum being added as well. So we would either recommend that gum is mixed with that sugar, or even put the gum on top of the sugar that's in the hopper. And then, as I say, that will act as somewhat of a plug, and then that helps to reduce the amount of air that's being entrained. The return pipe also, consideration should be given to that. The return pipe, normally we recommend, is below the surface of the liquid. So once the air has been pushed out of the pipework when the recirculation line has been started, then it's actually what we would call a closed system. So the lines are fully flooded and it's returning back into the vessel below the surface of the liquid. That should dramatically reduce the amount of air that's in the product, because pipework coming back in and it's splashing on top of the liquid can cause foam. And if that's not possible, another technique is to have the return line at a tangent to the ID of the vessel itself. That, in a way, creates a sort of fanning of the return liquid along the ID surface of the vessel, and allows for any air bubbles to actually burst. And also the liquid will then sort of fall down gently into the balance of the liquid. Question here is, can you pull liquids through the funnel of the flash mix? Yes, you can, but you've got to remember it's also where you're going to be adding your dry ingredients. So if you use it to absorb some liquid, you've got to be pretty sure that hopper funnel is thoroughly dry, the valve is thoroughly dry, because if you don't, then you'll have a bit of a sticky mess around that valve area once you start putting in the dry ingredients. An option of what we can do is to put an additional inlet to the powder manifold of the flash mix, where liquids can be pumped in using a simple volumetric dosing pump. So the various phases are introduced together just prior to the inline high shear mixer. So they're all mixed together in the engine.
We've also found that some customers will just pull all of the powders in through the hopper first, and then if they have any liquid ingredients or flavorings or anything else that they're looking to pull through that hopper, they can do so after, as Matt mentioned, so that way that hopper isn't wet when the powders are being added. The powders are instead added first, and then the liquids are added after to avoid the powders from sticking to the hopper.
Okay. Just looking at a number of the other questions here. Let's have a look. We have observed lumps in the product powder mix, several hours mixing with the laboratory silverson machine. What we could do to minimize that. That seems to be a reagglomeration of the solid phase. So that would kind of point to actually a review on the formulation. If the silverson is dispersing the powder initially and it creates a suspension, but then there is an attraction of those agglomerates coming back together, then that may be an issue with the emulsifier being used or something like that. So that on the face of it would seem to be more of a formulation question rather than a silverson machines question. Okay, another question. Which machine would you recommend for TiO2 in making white paste? It depends how the TiO2 is being added. We can use the flash mix. That works very well and would disperse the titanium quite readily. Other companies will actually, if they're putting a higher percentage of titanium into their formulation, would actually add it into the vessel, create a premix, and then use just an inline high shear mixer on a recirculation loop to disperse and ensure an even distribution, particle size distribution. So there's a couple of ways to approach that. As in most applications with silversons, there's always one or two ways to approach applications. So there's no sort of definitive one answer. There is a lot of discussions before we sort of would select and specify a machine. So, you know, batch sizes, percentage of powders, flow rates, etc. So, but that would be the two ways: either putting the TiO2 into the vessel or via something like the flash mix. Okay. Question here: what are the options available for powders that like to bridge or rat hole? You would have noticed when Zach was going through the flash mix range, a number of the vessels had an offset angle to the hopper, the feed hopper for the powders, and that is to overcome these powders that tend to rat hole. So what I mean by rat hole, this is where we're drawing the powders in, and the powders, due to their poor flowability or their cohesive nature, they will actually pull the powders, form a hole, and then you're just sucking air into your product. But using an offset angled hopper, so one side is sort of vertical and the other side is at sort of 30 degrees like so, the powder that's stacked up against the vertical side will tend to fall in on itself as the powder's being drawn in. So that's one way. We also have options for what we would call sort of like pneumatic knocking devices. Just something that sort of knocks the hopper, once every 10 seconds or something like that, that just creates a little bit of vibration in there to knock the powders and ensure that they fall in upon themselves. One other option is to polish the internal surface of the hopper. That works to a point, but over time that surface will become rough because of the powder sliding in. So that's not really a long-term option, but it's something that can be done as well. Okay, a lot of questions coming in. It's great, thank you. So a question from Leandro in Brazil, our rep out there. Hi Leandro, I hope you're well. What is the maximum viscosity of the liquid base that the flash mix can work for powder incorporation via the hopper as well as the wand, right? Okay. This is very much formulation dependent and depending on the rheology of the product itself. But in very broad terms, we have done gums and thickeners up to about 40,000 centipoise, something like that. And with the wands, we have done a 5% pectin mix before. And so that was around 25,000 centipoise, something like that. One of the products that we're often asked to mix is fume silica into resins. That, when you look at just bare viscosity measurements, that on the face of it should be quite an easy application, but the sort of elastic nature of resin and its rheology is actually quite difficult. So its stickiness and as I say, its elastic nature can actually present some challenges when putting fume silica in. So typically, if there's a large amount of fume silica going in, we would actually recommend that goes into the vessel first, gets pre-mixed, and then is recirculated through a high shear mixer. Okay, I'll just jump into the other chat room. I see there's some questions in there. Okay. So can you please give me an idea of the inlet pressure range required by the flash mix? Well, it's quite simply it is that we need it to be fully flooded and sort of inlet pressures of 0.2 bar, something like that, would be required. Very straightforward. What if powders float on the surface? So if the powder is floating on the surface of the liquid, this is what we tend to refer to as rafting or something like that, then you're clearly adding the powder into the vessel, and we're using something like a top entry high shear batch machine or the Ultramix. And really what we're trying to do there is to create a vortex to bring that powder down into the mixing vessel and be affected by the high shear mixing head or the Ultramix mixing head. Now, the challenge there is to not have too big a vortex, of course, because you put a vortex, you're pulling air in as well as the powder itself. So with our batch machines, we always recommend that they are mounted off-center. And by mounting them off-center, you will have a collapsing vortex. If it's mounted in the center, you'll get this perfectly symmetrical vortex, almost down to the mixing head. The liquid will rise up the side of the mixing vessel, wet your feet probably, and suck in a lot of air. So those of us who have worked with us in the past, those of you who've worked with us in the past, will know that we always offset the mixing head in the mixing vessel. And you would have seen that actually during Zach's presentation, where we were showing the laboratory mixer dispersing some of those powders, you would have seen that the head was off center and there was this collapsing vortex. Okay, let's just see what else we got. Quick one. Okay, so how do you choose between a top entry and a bottom entry high shear mixer? Well, it comes down to the objectives of the end user and also the type of product. The advantage of a bottom entry mixer is that you can actually continue mixing as you have a greater volume range or usable volume range in your vessel, because a top entry mixer will come down so far, and then once the liquid level has gone beyond the mixing head for the batch machine, it's no longer effective, and you can't run the batch machines dry. So if it's in the bottom, you have a lot lower minimum mix volume. The only trouble with a bottom entry mixer is that we have to have another mixer in there anyway. It won't pull product down from the surface of the liquid right down through the liquid and into the shear head. So it always requires additional mixing. They're very common with products, viscous products. So where in the vessel you have gate agitators or contra-rotating agitators, and you're doing very, very viscous creams, lotions, sort of cosmetics, that type of product, gels, toothpastes, that sort of thing. And with the use of those additional mixers in that mixing tank, they will actually create a flow pattern so the product actually goes down into the bottom entry high shear mixer. So it's really application driven. As I said earlier, we often have 2 or 3 options when looking at what mixer to recommend. So it does come down to the application and the requirement. So I haven't answered all the questions. Apologies to those that I haven't got back to. We will come back to you on those and answer them. I'd like to thank you all for your participation. I'd like to thank my colleague Zach, who took the brunt of the presentation and did a really good job. You can find our details, obviously, on our website, where you'll be able to find application reports, how to contact us, where those sort of den fleets are available, and where we have process laboratory and testing facilities available too. So just briefly to say thank you very much for your time, and I hope you found it of benefit. So thank you.
Yeah, I also want to thank you all for taking the time out of your day to join this webinar. We hope this information was helpful, and we'll look forward to providing a solution to your mixing needs. And if you already have a Silverson mixer, we thank you very much for utilizing Silverson and for considering Silverson. I did want to make you aware that we will be exhibiting the Specialty Agrochemicals America trade show next week at the Savannah Convention Center. We'll be at booth 110. We'll look forward to seeing those who will be attending that. And then, as Matt mentioned, for any of those additional questions that we didn't get to, or any other inquiries that you have, we can be reached directly at sales@silverson.com, or you could submit an inquiry on our website. Just include your complete contact details and a description of the application you're mixing or the problem you're encountering, and we'll be more than happy to assist.
And just one final point, those of you who are not based in the US, where Zach is, if you go onto our website, you'll be able to find the exhibitions that we're doing globally. Okay, thank you again, everybody, and hope to speak to you soon. Thank you.
Thank you all.